Imagine waking up one morning, logging into your bank, and everything is gone. Not stolen the usual way, not hacked with passwords or phishing. No, the encryption itself just stopped working. Every lock, every secret, every system we trust opened. Now imagine the machine that did that wasn't trying to break anything. It was just solving a math problem. And now imagine that same machine paired with an AI, not just calculating faster, but exploring millions of possibilities at once, learning from them, choosing the best outcome. Whoa, hold on, that's not science fiction anymore. That's a roadmap being built right now inside labs at Google, IBM, and places that don't even publish their research. But here's where it gets strange. Everything you've heard about quantum AI, it's half true, half illusion, because there are actually two completely different stories hiding behind that term. One is real, already changing industries quietly, and the other is a very expensive dream. So which one are we actually building? And more importantly, what happens if both become real at the same time? And to understand that, we have to go back to the very beginning.
Welcome to this video from Null Hypothesis.
All right, let's slow this down, because this is where most people get lost. And honestly, it's not your fault. Right, so a normal computer, your phone, your laptop, runs on bits, tiny switches, on or off, 0 or 1. Everything, videos, games, AI models, all of it is just billions of these switches flipping really fast. Simple. But a quantum computer? It plays a completely different game. Instead of bits, it uses something called a qubit. And a qubit can be 0, 1, or both at the same time. Yeah, I know, that sounds fake, but it's not. It's called superposition. And it's not like the qubit is secretly one or the other. It genuinely exists in both states until you measure it. Wait, think about that. It's like flipping a coin, and instead of landing on heads or tails, it's spinning forever, being both until you look. Whoa. Now, let's make this real. Imagine a maze, a huge one, millions of paths.
A normal computer tries one path at a time. Fast, but still sequential. A quantum computer, it tries all paths at once, and when you check the answer, it collapses onto the correct one. That's the power, not speed exactly, but possibility. The ability to explore massive combinations simultaneously. But here's the thing, this power is extremely specific. Quantum computers are incredible at certain problems, optimization, simulation, cryptography, but for most everyday tasks, they're actually worse than classical machines. So no, your next iPhone won't be quantum, at least not anytime soon. But this is where things start to connect, because once you understand this, you can finally see what quantum AI actually means and why most people are getting it wrong.
Okay, now then, let's address the elephant in the room, the term quantum AI. It sounds futuristic, powerful, almost magical, but it's actually being used in two completely different ways. And mixing them up, that's where all the confusion and hype comes from. So, version 1, using quantum computers to run AI. This is what most headlines are talking about. Training neural networks at insane speeds, solving problems instantly, building super intelligence. Sounds incredible, right? Yeah, except we're not even close. Current quantum computers, they're tiny, unstable, error-prone. This era even has a name, NISQ, Noisy Intermediate Scale Quantum, which is basically a polite way of saying it kind of works, but also kind of doesn't. Oof. Training something like modern AI models requires enormous stability and scale. We're talking trillions of operations. Quantum hardware today? Not there, not even close. And yet, billions of dollars have been poured into companies promising exactly that. So what's actually real? Version 2. And this is the part almost nobody talks about. Using AI to build quantum computers. Oh yeah, flip the relationship. Instead of quantum making AI better, AI is making quantum possible. And that's where the real revolution is hiding. Because quantum systems have a massive problem. They are unbelievably fragile. And solving that problem might require intelligence, but not human intelligence. Something else. And that's where things get interesting.
All right, now let's talk about the biggest obstacle in quantum computing: decoherence. Sounds technical, but here's what it means. Quantum states don't last. They collapse fast, like insanely fast. Even tiny disturbances, heats, vibrations, radiation can destroy the state. It's like trying to balance a pencil on its tip during an earthquake. Yikes. And to even run a quantum computer, you have to cool it to temperatures colder than outer space. We're talking near absolute zero. And even then, errors happen constantly. So how do you fix that? You can't just manually correct it. It's too complex, too fast, too unpredictable. So researchers turn to AI. And here's where it gets wild. AI systems are now being trained to monitor quantum hardware in real time, detecting patterns and errors, predicting failures, correcting them before they happen. Wait, that means a classical AI is stabilizing a quantum computer. Oh, think about that dynamic. One system learns, the other explores reality, and together they start to function as something neither could be alone. That's not hype. That's happening now, quietly, inside research labs. And once stability improves, everything else starts to unlock, which leads us to the first real applications. And trust me, they're not where most people expect.
Now let's step out of theory and into reality, because this is where quantum AI becomes tangible. Walk into a pharmaceutical lab today. Ask them what they struggle with. It's not data, it's simulation, understanding how molecules behave, because molecules don't follow classical rules. They follow quantum mechanics. And simulating that on a classical computer, almost impossible. You're approximating reality, not modeling it. It's like trying to predict ocean waves using Lego blocks. Clunky, inaccurate, limited. But quantum computers, they operate using the same physics as molecules. So instead of approximating, they simulate directly. Now add AI. AI suggests which molecules to test, optimizes simulations, analyzes results faster than humans ever could. And suddenly, you're not guessing anymore. You're exploring systematically, efficiently, powerfully. This is already happening in early experiments. Small molecules, controlled environments, but real progress. Now, expand that idea. Material science, designing new substances, stronger, lighter, more efficient. Even superconductors, materials that carry electricity with zero loss. If we crack that, energy grids become insanely efficient. Transportation changes, computation changes. Everything shifts. And then there's optimization. Traffic systems, supply chains, financial models, problems with millions of variables. Too many possibilities for classical systems. But for quantum, that's the sweet spot. And AI guides the search, finds patterns, chooses the best outcomes. So no, quantum AI isn't replacing your apps tomorrow. But it is quietly embedding itself into the systems that run the world. And that's where the stakes start to rise. Because there's one application that changes everything.
So now, here's the realization everything has been building towards. Quantum AI is not just a faster way to compute, it's a different way to understand reality. Let that sink in. Classical computing is about certainty, 0 or 1, yes or no. AI introduced probability, predictions, learning. But quantum computing, it embraces uncertainty, superposition, multiple truths at once. Now combine that with a system that learns, adapts, optimizes, and you get something entirely new. Not just intelligence, not just computation, but a machine that explores possibility space itself. Oh, humans solve problems by guessing. We narrow options, we try, we fail, we iterate. Quantum systems, they don't guess the same way. They explore vast possibility spaces simultaneously, and AI helps navigate that space, meaning problems we once thought were unsolvable start becoming tractable. Not easy, but reachable. That's the shift. Not smarter AI, not faster computers, a fundamentally new relationship with problem solving itself. And honestly, that's bigger than most headlines even capture. But there's a cost, and it's not small.
Let's not sugarcoat this. Everything we just described has a dark side. Because the same power that helps discover drugs can break encryption completely. Today, almost all digital security relies on problems that are extremely hard for classical computers. Take that hardness away, and the entire system collapses. Banking, communication, governments, everything. And here's the unsettling part. Some organizations are already preparing for that, collecting encrypted data today, storing it, waiting for the moment quantum systems are strong enough to decrypt it. Harvest now, decrypt later. That means data you think is safe today might not be safe tomorrow. And the transition to quantum-safe encryption, it's happening, but slowly, unevenly, globally inconsistent. Which means there will be a window, and whoever controls the technology during that window holds enormous power. So yeah, quantum AI isn't just a scientific breakthrough. It's a geopolitical one, an economic one, a security one. And we are already in that race, whether most people realize it or not.
So, we started with something almost terrifying, a machine that could break the world's encryption, and somehow we ended up somewhere much deeper and strangely more human. Quantum AI isn't just one thing. It's a convergence, a partnership, a quiet shift in how we solve problems and how we understand reality itself. And that's the part that really stays with you. It's not crashing into our lives all at once. It's not loud, it's not obvious, but it's here, growing, quietly, powerfully, shaping a future most people haven't even realized has already begun. And when you really sit with that, the question changes. It's not, will quantum AI change the world? Because it will. That part is almost certain. The real question is, who sees it early enough to understand it, to guide it, to shape what it becomes before it shapes everything else? And honestly, that's a little exciting and a little unsettling at the same time. So, if this made you think, even for a second, if it made you see things just a bit differently, then just sit with that for a moment. Because this is just the beginning, and the next shift isn't far away. In fact, it's already closer than it looks. And if you want to stay ahead of it, to keep exploring ideas like this as they unfold, then subscribe to this channel for more similar thought-provoking videos.
Thank you for watching. To view similar videos in future, do not forget to subscribe.